Okay, so I want to carry on from where we left off last week, and what we're going to do is use the law which we learned last week. The sum of the moments equals the moment of the sum, or the moment of the resultant. Sum, remember, is the resultant. So we're going to use that law now to find the centre of gravities of systems. So the first one we'll do is question 12 on your handout. Question 12 on your handout says you've got particles of weight 4, 10, p newtons and 7 newtons, and they're placed at certain positions around, say, an xy axis, and these positions are at 4 is placed at 3,8, p is 10 is placed at p minus 6, the p force is placed at 4q, and the 7 Newton force is placed at position pp. So these are our forces and these are our positions. Now we're going to use this, as I said, that law to help us find the values of p and q in that system. Now the other thing we're told is that the coordinates of the centre of gravity of the system are at 1.5q. Okay, so 1.5q is where the effect of these forces actually acts combined. So the resultant of these forces is, when you add those together, you get 21 plus p. Right, now the other thing, we're going to make up a table and we're going to find the moments of these forces about the x-axis, and we're going to find the moments of these forces about the y-axis. Okay, so force 4, remember moments is force by distance, so force 4, where is it? Well, it's at position 3,8, which, if you can imagine, I'll just put it down here, if position force 4 is at position 3,8, then it's up here somewhere, which means it's 8 units from the x-axis and 4 units from the y-axis, or 3 units from the y-axis. So this 4 Newton force, its position is 3,8, it's 3 units from the y-axis and is 8 units from the x-axis. So to find the moment, that's going to be force multiplied by the distance from the axis, and the distance from the x-axis is 8 units. The 4 Newton force, its distance from the y-axis is 3 units. So you'll notice that you're multiplying the force's position by its opposing coordinate. So this is the force multiplied by the y-coordinate to find the moment about the x-axis, and this is the force multiplied by the x-coordinate to find the moment about the y-axis. I'm going to do the same for the rest of those forces. So 10 will be multiplied by minus 6, 10 will be multiplied by p. Force p will be multiplied by q, and force p will be multiplied by 4. This p force, 7 force here will be multiplied by p, and the 7 force here will be multiplied by p also. Now I'm going to find the sum of the moments about the x-axis and the sum of the moments about the y-axis. And when I add these ones up here, this is going to become minus 28 plus pq plus 7p. And when I add these ones here, this is going to become 12 plus 21p. So now I have my information. I'm going to put this information into the law. So first of all, I look at the x-axis. What are the sum of the moments about the x-axis? This is my 28 plus pq plus 7p. And that's equal to the moment of the sum, or the moment of the resultant about the x-axis. So here's my resultant, 21 plus p. The moment about the x-axis is 21 plus p times q, because that's where it's acting. And I'll work through with this. So minus 28 plus pq plus 7p is equal to 21q plus pq. PQs will cancel, and I'll be left with minus 28 plus 7p equals 21q. Can't go any further with that. Continue down to the y-axis. So the sum of the moments about the y-axis is this one, 12 plus 21p, and that's equal to the moment of the sum or the moment of the resultant about the y-axis. The resultant is 21 plus p, and I'm going to multiply it by its x-coordinate, position of its x-coordinate, and that's going to be 1.5. So when I work this out, it becomes 12 plus 21p is equal to 31.5 plus 1.5p. 19.5p is equal to 19.5. P therefore is equal to 1. Now I have a p-value, I'll put that back in here. So this is minus 28 plus 7 is equal to 21q. Minus 21 equals 21q. Q is equal to minus 1. So I found the values for P and Q.